Hello everyone, and thank you for joining our webinar today. We're glad to have you with us. My name is Anna Flussner, and I'm here with Addin from Autodesk. Last week we announced the SimScale integration for Fusion 360, which is now available in the Autodesk App Store for you to download. And what this add-on does is it links our two communities by allowing Fusion 360 users to easily upload their 3D CAD models directly to SimScale. And for those of you who are Fusion 360 users and may not be so familiar with SimScale, basically we are a high-powered engineering simulation platform that can be accessed directly from a web browser. Okay, a little bit about myself. My name's Anna Flussner. I studied civil engineering at the University of Illinois, and I'm currently working at SimScale as the community manager, where I focus on supporting our community users and delivering trainings in the area of structural mechanics. I will throw it over to you, Addin, so you can introduce yourself.
Cool, thank you, Anna. I hope everyone can hear me all right. I was just fielding a question regarding a little bit of fuzziness in the audio. Anyway, real quick about me. I'm a mechanical engineer. I went to the University of Nevada, Reno. I've been in the software industry for quite a while as an applications engineer, and I focused on simulation products. Right now I'm technical marketing manager for Fusion 360 at Autodesk, so a lot of the YouTube videos you see on our channel are produced by me or my coworker Bryce. Pass it back over to you, Anna.
All right, thanks, Addin. So I'm going to go quickly right now through today's agenda. So first we're going to do an overview of SimScale. Then we'll go through, Addin will do an overview of Autodesk Fusion 360. And then we'll move into the demo portion of today's webinar. So Addin will go through designing with Autodesk Fusion 360. Then we will go through the SimScale add-in and show how that works and where you can get it in the App Store. And then I will take you through SimScale and show you a simulation that we have put together using the CAD model from Autodesk Fusion 360. Okay, so what is SimScale? We are a new generation engineering simulation platform that is directly accessible in a standard web browser. And so we use open source solvers supporting numerous simulation types, so mainly structural mechanics, fluid dynamics, and thermodynamics. And then we also have some acoustics and particle phenomena capabilities. And so SimScale is a complete simulation environment. So we support CAD upload, meshing, application of boundary conditions, simulation, and then the results. And so at SimScale, we're very excited to be breaking down barriers in the simulation world. So basically, traditional simulation tools are quite expensive and they require additional hardware and maintenance, and they can be really difficult to learn and to use. And we want engineering simulation to be accessible to everyone, from any computer, anywhere in the world. That's kind of our goal. And we also have a model where we think it's only fair that you pay for what you use, and so we have a subscription-based model with an additional community. So we have a community of 70,000 users and more than 20,000 public projects. I think that's about it. So Addin, I will let you go ahead with Fusion 360.
Perfect. Thank you, Anna. So Fusion 360 is an integrated 3D design tool. It's got integrated CAM and CAE tools. It connects your entire product development in one single platform, making it a pretty nice experience for anyone going from prototype to delivery. This includes things like industrial design via our T-splines technology, mechanical design with parametric design included in that, and mechanical drawings as well. We have renderings for your marketing imagery. We have some simulation capabilities, definitely not in the same range as what SimScale has to offer, but some stuff there to get you introduced to it at least. And then also we have the CAM workspace as well. But for me, coming from like a traditional 3D design tool, I think the thing that I find the easiest and most favorable thing about Fusion 360 is its ability to collaborate so easily and work with teams. Your data is stored on the cloud, making it very easy to share with other people. Anna actually shared a project with me to help us work together for this webinar that you're seeing today. So when you see me jump into Fusion, it's not actually a project that I started, it's a project that someone on her end started and shared with me. So I think with that, I'm going to go through a really quick presentation of Fusion 360. You can see the project that was shared with me actually. You can see if I go to my People tab here, I'm just one of the contributors to this group. I'm going to actually be showing you a real quick introduction of how you'd make something like this, the skateboard that we're going to be actually analyzing a little bit later. So I have a little modeling folder that I built into this project, and I'm going to go ahead and just start from scratch basically. So I'm going to start a new design here, and if you're not familiar with the skateboard here, I'll just open one up so you can get an idea of what I'm actually shooting for here. But you can see that the deck has some nice, some curvature to it. The trucks I'm actually going to import from an existing model, and then I'll build the wheels and maybe even put in some hardware as well, depending on how much time I take up. So let's see how I build that shapely deck, we'll call it. This is where one of those areas where the T-splines technology comes in incredibly handy. Doing that with a parametric surfacing technique would be not the easiest thing to do. So I'm going to actually go ahead and just select my create form from my toolbar. Here I'm going to select from the create drop down to create a plane. Now it's looking for basically a sketch plane in which to drop this square onto, essentially is what it's going to be. So I'll select the top plane here, and now to center this rectangle that we're going to be using to create this T-spline shape, I'll just put it on the center of this workspace. Now as I drag out, you can see it's actually enabling me to maybe key in some dimensions here. So I'm going to make this 30 inches wide total, and I think 30 inches long and 8 inches wide. And when I click, you can start to see this T-spline shape coming together. And one of the major benefits of this tool is that you don't have to create overly complex surfacing tools here. You can actually just insert as many edges or faces as you need to get to the shape you're after. So I'm going to actually just kind of click and drag on some of these handles to get to an appropriate number of control faces to use here, and I'll just drag one way or the other, accommodate or to the complexity level that I'm after. One way to definitely reduce the complexity, leverage symmetry. So I'm going to use the drop down here to mirror my options using both the length and the width symmetry. I'm assuming this skateboard it's going to have symmetry both in the length and the width directions. So we'll key in some values there. I'll click OK, and just like that, now I have this nice workspace, or this nice plane that I can move and drag and manipulate essentially in any way, shape, or form. So I'm going to use the tool that I'll use about 95% of the time when I'm in my sculpting environment, this Edit Form tool. And using this, I can click on edges and drag them up or down to kind of accomplish different shape changes. And you will notice that not only is it changing on this end, mirroring over this green line that you see here, but also on the opposite end of this skateboard as well. So that was by design. That's what that symmetry was that I built into this. I'm going to undo that change, and actually, before I even do that, I want to just delete this vertex here. So when I select it and hit delete, it's going to actually round off that corner for me and start to get to a more skateboard shape that you'd expect to see. So I could click and drag these things. I can actually move my lines around. I can move vertices around, and again, all of this is just to try to get to an appropriate shape for this design that we're working on. I'll select that end edge again and kind of drag it up a little bit. Maybe I'll select this vertex here and drag it up a little bit. There's usually kind of a nice little lip on the end there. And again, just kind of clicking and dragging and sliding things ever so slightly, I can make quick changes to get to a very complex shape in a pretty short amount of time. I'm going to do one more little adjustment there, and I'm just kind of rotating around. And no, maybe I don't like that. You can always undo or reverse the change that you just did there. So that's looking all right. Not the best iteration that I made, but I'll go ahead and finish that form. And just like that, it's actually just a thin piece of geometry. It has no thickness to it, so I can actually use my S key to find my Thicken tool, And this is just a real quick shortcut to find your commands that you might be looking for. I'll select that form, and then I'll maybe key in a value here, and I want it to be maybe a 1/4 inch thick. Once I key that in, this is actually solid geometry that I could take, and I could start to produce this if I had a CNC in this hotel room where I'm actually doing this presentation at. So let's go ahead and actually do a couple other things here. You know, the edges are pretty sharp right now. I can round those off, and I'll use my press pull tool to do things like extrude, cut, offset faces, and in this case I'm using it to do a quick fillet. I'll make that 0.1 inches, appropriate size for this 1/4 inch thickness board that we have here, and click OK. And that looks alright, but you know, a way to make it look really good is to apply appearances. I access this appearance menu by hitting the A key on my keyboard. I'm going to find this solid wood style display and just drop it right on there. We'll close out of this dialog, and you know, that's just one single body and what is going to be made up of multiple components in this design. The trucks themselves I'm going to actually insert from another design, but one thing I want to do, and this is actually something that I should have done from the beginning, is I want to assign this body a name. I'm going to call it deck, and I'm going to turn it into a component. The components is really the way that you're going to share your parts with other designs, and it's good to create your component from the get-go using rule number 1. I'll right click, I'll create a component from this body, and now I'm going to start to add other pieces to this design. So at this point I'm going to jump over to my data panel, and you can see the trucks here. These were just, you know, provided to me from another design that I might have worked on. So I'll just right click and I'll insert it into my current design. And it's asking me to save, so I'm going to give it test2 name. Once it's saved, I can then go ahead and right click on this and insert it into my design. It is going to orient properly. That's just kind of lucky because it's centered on what I've been building on previously, but I can, you know, move these up and down or use things like joints to place them properly. These externally referenced or distributed designs, if you want to call them that, will show this link there. These trucks are uneditable unless I break that link, but in this case I'm not going to be making changes to that, so I'll just close my data panel. And the next thing I need is a riser that's going to connect between the trucks and the board themselves. So I'm going to do this in the proper way this time. I'm going to create a new component here following rule number 1. I'm going to select a name, I'll call it riser, and the parent is going to be the top level name, and you can see that's test v2, test 2 version 1. I'll go ahead and click OK, and now this is activated. So at this point I'm going to hide the deck itself, and I'm going to insert a sketch onto the top of where the trucks are, and then I can project those shapes into the sketch that I'm working on. So I can hit my P key, it's going to pull in any of the geometry that I want to bring into this. I can select that body, those two bodies, to bring in that shape. At this point I can extrude these shapes, and I can extrude both sides at once if I'd like. And right now it's, you know, not quite the right size, but that's okay. I'm going to fix this in just a moment. I just want to make sure that those pass actually through it so that I can create a cut with the board itself to ensure everything fits together perfectly. So at this point I'm going to use a combine tool. This combine tool I use for a lot of different things similar to that press pull tool, but in this case what I want to do is I want to ensure that my target body, which is going to be both of these risers at some point, are cut by the tool body, which in this case is the deck. Here I want to change this to cut, and it's actually going to change the coloration. It's going to show me it's using that deck to actually cut away from the riser itself. And I'm going to say to keep the tool. I'm actually using the deck itself here to make a cut, but I don't want it to go away, as you might guess. I'll click OK, and that's going to ensure that that riser fits to that deck, no matter how the shape might change, no matter how I might go back to the T-splines and refine the shape that we have at that point. I'm going to do a combine once again, and here's a nice little quick shortcut for you for those Fusion users out there. I'm going to right click and hold. It's going to bring up my marking menu, and I can repeat that combine tool. I knew I'd do it a second time, so I'll just select the target, the tool, cut, keep tools, save the options from last time, and we'll click OK. And it's looking pretty good, except I have those extra bodies on type, and I can just go find those from the folder here and remove those out if I wish. So looks like it's the top two. just control select both of those at the same time and right click and select remove. There we go. It's looking pretty good. So, you know, as I mentioned, this isn't all about Fusion Design. I think I'm pretty happy with where it's at right now. So what I want to do now is I want to show you how to connect your design to SimScale so you can actually go and do some of these advanced simulations that they have at their disposal. So SimScale is an add-in. I'm going to use the drop-down under the add-ins list to access my Fusion App Store. And that brings up a different window here, my Chrome window, and here you can see various apps that we have available, and on the first page itself you'll actually see the SimScale app accessible from there. When I click it, you can see a little bit of detail about what it includes. You'll see some videos and some screenshots and even some reviews. There's a positive review already, which is pretty great. You can see it works on actually the two operating systems that we support, Mac and Windows. And so in this case, I'd select the Mac OS and download and install it. It's a 2.6 megabyte download. It installs in no time at all. I've actually already installed it, so at this case I'm going to just turn it on using my file drop down here from within Fusion. I'm going to access my scripts and add-ins. You don't actually have to do this. Once you install it, it will automatically be added in. I just had it off because I wanted to show you what it looks like when you add it in. So I'm going to actually select to run it on startup because I do want it to run all the time. I'll click the run button. And what you get when you install this tool is you get this SimScale dropdown on the far right of your toolbox. So at this point I could go and I could launch the SimScale add-in. I'm going to select that button and I can log into my account, and just like that I'll be able to then upload this geometry and have access to all the different types of simulations that SimScale has at its disposal. So I think at this point maybe I'll pass it back to you, Anna. I think you're going to talk about some of the details related to that.
Sure, I will, let me grab my screen here. Okay, so right now, I wanted to start quickly. I will show how this add-in works, and I will directly pull basically one of our models into this project. So right now I'm on my SimScale project called the skateboard project, and you can see from this viewer that I've only added the full model of the skateboard. And so what I would like to show is basically when you do simulation, it's really smart to use symmetry. And so it's better if we're going to do a simulation on this model to use a quarter model. It'll be much more computationally efficient to do the simulation in this way. And so I as well, I have the SimScale add-in already ready to go. And so I can launch this. And so I've already logged in. And so basically what happens is I can take this quarter model and insert it into my skateboard project. And so that's what I'm going to do right now. And then I select Upload to Project. And so this will take a little bit, and so it says right now it was successful, so I can just click OK. And right now I will go back to the SimScale platform, and we can do a refresh here. And we should see that this is popped into the project. And so you can see right now, I now have this quarter model in the project. So I can open this, and we can just quickly have a look. So yeah, here's the model in the viewer. It's perfect, it's ready to go. It's a solid model. It's made up of, it looks like nine solids. And so now what I want to do is we can kind of talk about how we would set up a simulation on this. So you can see that it's been added. We have our CAD model. What we're going to do is a dynamic drop test. So when you basically jump onto a skateboard, there's this kind of dynamic load of the person being added to the skateboard. And so we can model this in SimScale using a dynamic analysis. And so after the CAD model has been uploaded or dropped into this from Fusion 360, the next step is to mesh the model. And so I can show this really quickly. We have it selected here, so I will just add a new mesh. And you can see now we're in the mesh view. And so SimScale has many different options for meshing. For an FEA analysis that we're going to do, we would use tetrahedral meshing. And so right now, I will just show the simplest type, which is tetrahedral automatic meshing, and we can just do a first order. You have the option of which fineness you would like to use, especially at the beginning when you're first starting an analysis. It's good to just do a coarse mesh. So we can just select that and then use 4 cores. And that's really it. So this is a very easy way to set up an initial mesh. And I would just click Start here. And what will happen is this, you can see down in the bottom left that the mesh operation has begun. And so this can take, 5 to 10 minutes for the meshing to actually work. And so the idea is I can kind of show you, I have another window open basically where this analysis has already been done. And so we can kind of go through this. We have a tutorial set up already in our forum. So if you want to go through all these steps, this is going to be available, and I will show that at the end of the presentation. So it takes some time to set up these analysis, time that we don't have in this webinar. So I will take you through it, and then you can go through it on your own after the session is over. So if we have a look here, I've created a mesh. You'll notice that this mesh, we did this mesh with tetrahedral with local refinements, and so basically this allows for more control over your meshing. You can see that we have a very coarse mesh for the ground because this is rigid. We don't really need a fine mesh here. We're not interested in the stresses at all at this point. But if I zoom in here, you can see on the aluminum truck that we have definitely added some refinement because we're going to notice higher stresses at that point, and that's what we're interested in seeing. Okay, so the next thing is after you do the meshing in a simulation, you have to set up your boundary conditions. So first of all, we've selected an analysis type. This is a solid mechanics analysis, and we're doing a dynamic analysis here because for you can only use static analysis if it's a system that's being loaded slowly. And so in this case, when someone's jumping on a skateboard, we have a very quick load. It's a dynamic analysis. So we're going to use the dynamic analysis advanced option. And the difference here between not advanced and advanced is just that we have different solvers working in the background. And so you'll find that these advanced options always give you more options for constraints and for loading. So we generally recommend using these advanced options in any case. The next thing I can talk about are topological entity sets. So here you notice on this model that there are a lot of faces. We can see these faces over here. So there's probably at least hundreds of faces on this. So we can create entity sets. For example, we know that we're going to use symmetry in the Z direction. And so we can group these faces together to be used later when we're setting up our boundary conditions. The next thing to talk about is the bonded contacts. And so as I talked about earlier, you can see that we have 9 volumes here. And with simulation, these, the system doesn't know that these are in contact unless you set it up and create contacts between each body. And so that's what this bonded contact is doing. So you can see, I can try to show you an example here. So right now you can see the master contact and the slave, and we can show these. And so if I hide, if I hide this, you can see that this face is being connected to this, and you do that throughout the model where contacts are, just to get all 9 of these volumes connected to each other. Now, if I go to physical contact, this is what we see here. So this will be the impact. This is what we use for showing the impact, basically. And again, you can see this is one face, and then the other face will be the wheel as it hits the ground. The next thing, we obviously have to set up materials here. So you can see that the deck of the board is wood, as Aaron showed earlier. He was using wood in his model, so this is a wooden deck. The truck here is aluminum. We have wheels. Wheels and some of these intermediate pieces are all rubber, or they're like a plastic material. The ground, I'll select that, concrete. And then this foot load here. So this, you can see this has a very high density. And this is because we're including the weight of the person in this material load. Okay, the last thing we have to do is the boundary conditions, and so obviously when this board is dropped, it's going to have an initial velocity, and so this has been labeled as dropping velocity, and so we're going to say that this has a downward initial velocity of 2 meters per second in the downward direction. And then the final constraints that have to be applied are obviously the symmetry that I talked about earlier. So as you can see, we apply symmetry in the Z direction as well as the X direction here, since we're only using a quarter of the model. And then we also have to fix the ground. If we don't fix this ground, we're just going to have rigid body motion. So we want this is an immovable piece, or this does not move at all, so it's completely fixed in all directions. And I think that's really the main points to go through. Like I said, we have a step-by-step tutorial, so you can go through all these steps that we're doing and have a look. I don't want to take too much time to go through all of this. Let's see. I think our meshing operation on the other side is still going. So the last thing that obviously we would want to look at is, we can see that the runtime was about 18 minutes on this. So like I said, it takes some time to run a dynamic simulation like this. So that's why we're not going to go through every single piece of the setup. And the last thing we would be interested in looking at is the results. So we can go into post-processing and we can see the results of this. And one thing that we have is we have these filters, so you can really you can play around with those and